problem is clear, right sir? This is one such example where you can use numbers in place of variables and you can solve it, right? Now, another example where you can classically use numbers and solve number system questions, sir. Number system is basically a number, sir. Please try to use numbers and variables. Variables is nothing but algebra, sir. Right now, see here. Please see the next question. Your next question says, consider a sequence of 7 consecutive integers. The average of the first 5 integers is n. The average of all the 7 integers is how much? Right now, see here. They are asking, consider a sequence of 7 consecutive integers. Instead of taking as a plus 1, a plus 2, a plus 3 and working out with variables, take 7 consecutive integers. The easiest 7 consecutive integers is first 7 natural numbers. These are the easiest ones. You can take any others of your choice. The average of first 5 integers is n. Average of first 5 integers. This is given as n, right? This is given as n. So n. What is the average of 1, 2, 3, 4, 5? Average is nothing but the middle value because it is in arithmetic progression. We already discussed in averages topic. Now, the average of all the 7 integers is how much? Now, they are asking you the average of all these 7 integers. Average of 1, 2, 3, 4, 5, 6, 7. This is again nothing but the middle value 4. So 4 is nothing but if n is 3, 4 will be n plus 1. So answer in the options should be n plus 1. N plus 1 is option B. Answer should be n plus 1. You can easily solve a number system questions by applying a number rather than variables. Do not waste your time by taking it as a plus 1, a plus 2, a plus 3, all those things, which is nothing but an algebra method. Algebra is variables, number system is numbers. Let us create some numbers of our choice to make our simple question simple. Idea clear? Please write down. Please write down the next topic, sir. We will solve some CAT questions on 2000. Whatever the questions, number system questions which were asked in the year 2000, we will solve it right now. I hope 1999 is clear, right? Now, please see the first question. These are very easy questions which were asked in the exam, sir. Now, please see the first question. Let D be a recurring decimal of the form. D is equal to, the D value or the form is given by 0.A1, A2, A1, A2, A1, A2. Like that it keeps on continuing, and they are telling that where the digits A1 and A2 lie between 0 to 9. The A1 and A2 digits, these digits A1 and A2, it lies from 0 to 9. That is what they are telling. Next, second statement. Further, at most one of them is 0, right? At most one of them is 0. That means maximum one should be 0. Both cannot be 0 is what they are telling. Both should not be 0. Maximum one of them can be 0. That means none of them can also be 0. That is the meaning of it, right? Both of them need not be 0, or at least maximum one should be 0. It cannot be both zeros. That is the meaning of it, right? Now, which of the following numbers necessarily produces an integer when multiplied by t, right? Necessarily produces an integer when multiplied by t. Your options are 18, 1, 198 and the last option is 2. Now see here, there are two ways of solving this question. Suppose if I solve it in method 1, right? If I solve it by the first method. Now D is given as 0.A1A2, A1A2, A1A2. This is a recurring decimal, right? For a recurring decimal, if I want to convert it to a fraction, multiply with 100. Suppose if I multiply with 100, why am I multiplying by 100? Because 100 into D is, this decimal will shift after 2 places. It becomes A1, A2 point, A1, A2, A1, A2, A1, A2 and like that it continues. If I subtract this from this, 100D minus D is 99D. A1, A2 minus 0, it is A1, A2. After decimal A1, A2, A1, A2, A1, A2 will cancel with this A1, A2, A1, A2, A1, A2. That is the reason we are multiplying by 100, right? Now, D will be equal to A1, A2 divided by 99, right? D will be equal to A1, A2 divided by 99. Now, they are telling in the question, which of the following numbers, these numbers necessarily produces an integer when multiplied by D. That means this D I should multiply with any of these integers so that, or any of these numbers for that matter, so that this D should become an integer. Now what is the meaning of it should become an integer? I should not have this fraction, I should not have this denominator. That means I should cancel this 99. If I want to cancel this 99, what number I should multiply this with? Any multiple of 99. but out of the given options, the only multiple of 99 is 198. So I should multiply d with 198, so that 198 by 99 will cancel out and you will not have a fraction, it becomes an integer, right? Answer for this question is 198, right? Now this is one way of solving by a traditional method, by using all those subtraction, 100D, all these methods. The other way of solving is, question says at most one of them should be 0. That means maximum any one should be 0, or both need not be 0. Both of them should not be 0. That is what they are telling us, right? Both of them can be a non-zero integer. That is what they are telling in at most. At most means maximum one should be 0. Now see here, take some numbers of your choice, whatever number you want. Suppose if I make a1 as 0, d becomes 0.09090909. Like that it keeps on continuing. 0.0909, all these things is nothing but 1 by 11. If you remember, we discussed in fraction to percentage. 1 by 11 is 9.09 percentage. This is nothing but 9.09 percentage. Now this is a fraction. I don't want to have fraction, I want to have an integer. To make it as an integer, I should cancel this 11. If I want to cancel this 11, I should multiply d with any multiple of 11. The only multiple of 11 in the given options again is nothing but 198. 198 is nothing but multiple of 11. 11 into 18 is 198. That means again if you use some numbers rather than this variables method, still you will get the answer as 198 itself. Or you take any other number. It need not be 0.090909. Suppose d is 0.454545, etc. This is nothing but d is nothing but this is 5 by 11. Again I don't want to have fraction. I should cancel this 11. That means I should multiply by a multiple of 11. 198 is a multiple of 11. Getting the idea? Any one should be 0. Both of them also need not be 0. But both of them cannot become 0. That is what the meaning of at most is, right? That means a1, a2 you cannot put it as 0, 0. If you put 0, 0 for a1, a2, the number becomes 0. You cannot multiply the 0 with anything, because 0 multiplied by any number will always become 0. Idea clear? So please write down this method. Method 1 by using a traditional method, algebra way of solving. Method 2 is by putting some numbers and number system way of solving. Whichever you feel like you are comfortable, please follow that method. Please write down this. I hope it is clear, right, sir? First problem. Now please see the next question. Next question says, if n square is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. You are asked to find the value of n, right? You are asked to find the value of n. Now, it's a very easy question, but students will think that it's a difficult question. Now, the same way of solving or the same variety we have discussed in our speed math session. For the people who know the speed math session or who have watched the speed math session, it will be a very easy question. Now, listen to this carefully. I'll just give 1 or 2 examples so that you will remember what we have discussed in speed math session. Suppose we discussed a session or a concept called as squares of numbers containing only ones. I want to find the square of a number which is having only ones. For example, 111 whole square. Step number 1. How many ones are there in this number? 3 ones. If there are 3 ones, start from 1, write till 3. After writing till 3, come back to 1. 2, 1, 1. Suppose 11111 whole square. 1 written 5 times. Step number 1. There are 5 ones. Start from 1, write till 5. After writing till 5, come back to 1. 4, 3, 2, 1. Now if you observe the given question says, start from 1, write till 9. After writing till 9, come back to 1. 8, 7, 6, 5, 4, 3, 2, 1. That means this number is nothing but a square of a number containing 1 written 9 times, right? If I write 1 written 9 times and if I square it, the result will be nothing but start from 1, write till 9 and come back to 1. That means n value for this should be 1 written 9 times. 1 written 9 times. So answer is 1 written 9 times. It's a very easy question because we have discussed the same logic in our speed math session also. Idea clear, sir? Please write down. Clear, right? It's a very easy concept, unit digit concept. Please try not to apply any textbook methods for unit digit concept. It's a waste of time applying that method. Now see here. 6th question. A number is formed by writing first 54 natural numbers in front of each other as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, etc. Your question is, find the remainder when this number is divided by 8. Right? Find the remainder when this number is divided by 8. Now they are telling that remainder when the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Last number is, it is said that the number is formed by writing first 54 natural numbers. The previous last is 53, last is 54. What is the remainder when this number is divided by 8? Now, very easy question. It just looks like a difficult question, but it's actually a very easy question. You already know the divisibility rule of 8. Divisibility rule of 8 is nothing but last 3 digits should be divisible by 8. That means I can also write it as remainder when 354 is divided by 8. What is the remainder when 354 is divided by 8? 8 into 4 is 32. Another 3 is pending. 34. 8 into 4 is 32. 2 is the remainder. That means remainder when 354 is divided by 8 is 2. Remainder when the first 54 natural numbers are written and divided by 8. That also should be 2. It is nothing but the divisibility rule of 2, what we have discussed in our school days. Idea clear? The question looks very difficult or little lengthy by using all the first 54 natural numbers. The examiner will make you to try to make you confused, but it's actually a very easy question, sir. You should be good in concept and you should be good in understanding the question first of all. Idea clear? Please write on this question. Please see the next question. What is the unit digit in the units place of 2 power 51? That means they are asking you the unit digit of 2 power 51. Now please listen to this carefully. This we have already discussed in unit digit concept. Please do not apply separate concept for 2, 3, 5, 7, all those numbers. We discussed a beautiful concept saying as the generic cyclicity of unit digit of any number is always 4. Right? The generic cyclicity is always 4. That means try to express it in the form of 4 into something plus something else. Right? 4 into something plus something else. That means can I write it as 4 into 12 plus 3? 4 into 12 plus 3 is nothing but 51. We already know the concept that a power 4k plus 3 unit digit will be a power 3. So answer should be 2 power 3. 2 power 3 is nothing but 8. How you got this a power 4k plus 3 as a power 3? This is the complete thing what we have discussed in detail in our unit digit concept. I request you to refer that video for a better understanding of this problem. I think a power 4k plus 1 is a power 1, a power 4k plus 2 is a power 2, a power 4k plus 3 is a power 3, a power 4k. That means if the power is exactly multiple of 4, then it is a power 4. How you got it? The proof was also explained in unit digit concept in the regular class. First write down this proof. Now, next question. Now, next one is a very good question, sir. Please listen to this carefully. Fourth question. How many 5-digit numbers can be formed using the digits 2, 3, 8, 7, 5 exactly once such that the number is divisible by 125? Right? Now see here. They are asking you to form a 5-digit number. Right? They are asking you to form a 5-digit number. And they are also telling that you need to only use these digits 2, 3, 8, 7, 5, and you should not repeat the digits. Repetition is not allowed. Right? Repetition is not allowed. They are telling that you should use it exactly once. That means you should not repeat the digits such that the number is divisible by 125. This number should be divisible by 125. Now, what is the divisibility rule of 125? Divisibility rule of 125 is last 3 digits should be divisible by 125. That means first of all, what are the multiples of 125? Multiples of 125 are, let us write the multiples of 125. 125, 250, 375, 500, 625, 750, 875, 1000. Like that, this keeps on continuing. Right? It keeps on continuing. Now they are telling that this number should be divisible by 125. That means the last three places should be any of these digits, right? Should be any of these digits. But 1000 I can't take, I can take 000. Next number is anyway 1125. That is nothing but 125 only, right? The pattern continues again, right? Now see here, any of these digits should come and sit in the last three places. Now they are telling that you should only use these three digits, 23875. But I don't have 1, so it is ruled out. I don't have 0, it is ruled out. 375, I can use it. This is a possibility. 500 ruled out. 625 ruled out. 750 ruled out. 1000 also ruled out because 0 is not there. That means I can use the last three digits as either 375 or I can use it as 875. These are the only two possibilities, right? These are the only two possibilities. That means I can say that these three digits, it can be 375 or the last three digits, it can be 875, because divisibility rule of 125 is last three digits should be divisible by 125. These are the only two cases which will come under this given numbers. Now, if I use these three numbers 375, there are only two other numbers remaining, 2 and 8. It can be 2 and 8 or it can be 8 and 2. Two different numbers can arrange among themselves in how many ways? 2 factorial ways. Similarly, here, if I use 875, it can be 2 and 3 or it can be 3 and 2. Again, two different numbers can arrange among themselves in how many ways? 2 factorial ways. So your answer should be 2 factorial or is nothing but addition, which we have discussed in permutation combination. 2 factorial plus 2 factorial. What should be the answer? Answer should be 4. Question they are saying as how many 5-digit numbers can be formed. How many you can form it? You can form 4 5-digit numbers. Suppose if the question is asking what are the 5-digit numbers, still it's not a difficult task. So it is 375 is done. So it can be 2 and 8, 8 and 2. 28375 is the first number. 82375 is the second number. Here 875 is over. 23875 is the third number. 32875 is the fourth number. These are the only 4 numbers that can be formed using these digits without repeating the digits, which are divisible by 125. I hope it is clear, right? If you are still not clear, I suggest you to watch our permutation combination videos so that you will understand this kind of problem so beautifully. Idea clear? Please write on this. Now we will solve some questions on CAT 2008. Now please write down this first question. Your first question says, what are the last two digits of? What are the last two digits of? What are the last two digits of 7 power 2008? Right? You need to find the last two digits of 7 power 2008. And the answer options given are. Now what are the options given, sir? The options given are 2161. 2161, 01, fourth one is 41, option E is 81, right? These are the 5 options given. Now see here, what are the last two digits of 7 power 2008? Now 7 power 2008, this is nothing but our type 3 in finding the last two digits, when the unit digit is 3 or 7, that is what we are discussing. Can I write it as 7 square to the power of 1004, right? 7 square to the power of 1004 is 7 power 2008. 7 square is 49. 49 to the power of 1004. 49 negative remainder. We have discussed all these kind of problems in our regular classes. Negative remainder is 51, minus 51. Minus 51 power 1004. Minus power even is positive. It is 51 power 1004. Then when the unit digit is 1, type 1 we have come back to, right? These are all discussed in our regular classroom sessions, right? Now 1 power any number is 1. 5 into 4 is 20. In 20 what is the unit digit? 0. So answer should be 0, 1. Now this is one way of solving. Your answer is 0, 1. Getting the idea? Now listen to this, sir. This is your method 1. Now method 2 for this particular given options, it may not be useful, but I will tell you the trigger how method 2 is very useful if the options are different. Now listen to this carefully. Method 1 is what we solved just now. Method 2. If I solve by using method 2, now think logically. What are the last two digits of 7 power 2008? Now I need to find the last two digits of 7 power 2008. Now you take any number of your choice, make the power as an even number, make the power as an even number. That number will become a perfect square. For example, 3 power 4. 4 is an even number. 3 power 4 is 81. 81 is a perfect square. 4 power 2. 2 is an even number in the power. That is a perfect square. 3 power 6. That is also a perfect square. Suppose 4 power 4. 4 power 4 is 260. 4 power 4 is 256. That is also a perfect square. You take any number of your choice. 2 power 6. 6 is an even number. That is also a perfect square. Right? So 2 power 6 is 64. That's a perfect square. Any number you take in the base, make the power as an even number. That number will become a perfect square. That means 7 power 2008 is a perfect square. Again 7 power 2008 is a perfect square. Now, just now we discussed perfect square concept in the previous CAT exam paper, 2007 CAT exam paper. A perfect square will never end with 2, 3, 7 or 8. That is one concept. Now 7 power 2008 is a perfect square. Now observe the answer options. If you observe the answer options, all the options are ending with 1. Right? All the options are ending with 1. What is the behavior of a perfect square which ends with 1? 9 square is 81. It is a perfect square ending with 1. 11 square 121. 19 square 361. 21 square 441. Any perfect square ending with 1. Any perfect square ending with 1. 10th digit should always be an even number. Right? 10th digit should always be an even number. But unfortunately in the given option, that is the reason I told this method 2 is not that compatible for the given options. Unfortunately in the given options all the 10 digits are even numbers. Suppose for your luck, by your luck, suppose the options are 0, 1, 31, 51, 71. Suppose these are the given options. You need not do all these things. Any perfect square ending with 1. 10th digit should always be even number. Out of the given option, this is the only even number where 10th digit is even. This is the only option where 10th digit is even. That means you can mark. But in the given actual examination question, all the value 10th digit is an even number. So from method 2, actually you cannot solve from the given options. But I am giving you a trigger how to solve it. Right? That means this is a perfect square. Perfect squares are ending with 1. Any perfect square ending with 1, 10th digit should always be an even number. If these are the options, for example, that means if there is only one option where 10th digit is an even number, you need not apply the regular process. You can directly mark that option. That is what I am telling. Getting the idea? I am only telling that this method 2 is nothing but an acid test. Before you actually perform the original method, first check out whether this method can be applied for the options. If you think like these are the options and you cannot apply method 2, then do it in the regular method. There are multiple methods, sir. You pick up which is the best method for you. I hope the method is clear, right? Please write down it. Now, we will solve some questions on CAT 2007. Now, before we start with the first problem, first you need to know some concept behind perfect squares. This is already discussed in our regular class, but still I will take 2 examples for your understanding. Now first write down a point. A perfect square never ends with. Please write down this point, sir. A perfect square never ends with. A perfect square never ends with 2, 3, 7 or 8. Very, very important point. A perfect square never ends with 2, 3, 7 or 8. Right? What is the proof for it? That we have discussed in our regular class. Now see here. 2 problems I will discuss before we move on to the actual CAT question. Suppose is 5, 3, 1, 4, 8 a perfect square. Right? Is 5, 3, 1, 4, 8 a perfect square? What should be the answer? No, because just now we discussed a perfect square never ends with 2, 3, 7 or 8. It is ending with 8, therefore the answer should be no. Right? So answer is no. Suppose just listen to another 2 questions. Is 1, 2, 3, 4, 6, 6 a perfect square. Right? Is 1, 2, 3, 4, 6, 6 a perfect square. Now many students will tell the answer as yes, which is an incorrect answer. Why? Because now see here, what is my statement? A perfect square will never end with 2, 3, 7 or 8. I did not say that vice versa is also true. What is the vice versa? Any number which is not ending with 2, 3, 7 or 8, it is a perfect square. Did I say the statement? No. It is ending with some other number other than 2, 3, 7 or 8, 6. But it need not be a perfect square. For example, 36 is a number which is ending with 6. It is a perfect square. 26 is also a number which is ending with 6, but it is not a perfect square. That means any number ending with other than 2, 3, 7 or 8 may or may not be a perfect square, right? It may or may not be a perfect square. That means the answer for this question as of now is may or may not be a perfect square. But let us go one step forward to identify what is the correct answer. Now think logically. Suppose assume this as a perfect square, right? Assume this as a perfect square. It is ending with which number? 6. Now you take any number, any perfect square which ends with 6. For example, 4 square is 16. It is a perfect square ending with 6. 6 square is 36. It is a perfect square ending with 6. 14 square is 196. This is also a perfect square ending with 6. 16 square is 256. It is a perfect square ending with 6. Like that, there are so many perfect square which ends with 6. Right? Now observe carefully. Any perfect square ending with 6. Any perfect square ending with 6. 10th digit is always an odd number, right? 10th digit is always an odd number. But what is the 10th digit in the given question? 6. That is an even number. Therefore, the given number is not a perfect square, right? Therefore, the given number is not a perfect square. Idea clear? The same analogy we will use it to solve one of the very trickiest question in CAT examination with the most easiest method, right? Before we solve that particular question, first write down these two problems. Please write down this one. Idea clear, right? Now see here. Using this concept, let us solve a very interesting and a very tricky question in the most easiest way possible. Now please see the first question in CAT 2007, sir. Now first let us read the question. Consider 4-digit number for which first 2 digits are equal and the last 2 digits are also equal. How many such numbers are perfect squares? Now what they are telling in the question is, it is a 4-digit number. First 2 digits are same, last 2 digits are also same. How many such perfect squares exist is the question. Now see here, just now we discussed if it is a perfect square. First of all, they are telling that this should be a perfect square. Perfect square will not end with 2, 3, 7 or 8. It will not end with these 4 numbers. The key point is there above itself, right? Now see here, can it take 0? Yes, sir. If it takes 0, any perfect square ending with 0, it will always end with even number of zeros. If this is 0, this will also become 0. That means one of the cases B value is 0, right? This is one of the cases. Now can it be 1? No, it cannot be 1, because if this is 1, perfect square ending with 1, 10th digit should be even, 81, 121, all those things. But if this becomes even, these two values should be same, but 1 and 1 is not an even number, ruled out. It cannot be 2, it cannot be 3. Can it be 4? Yes, that is also a possibility, because any perfect square ending with 4, 10th digit should always be an even number, 64, 144. 4 is also an even number. This can be a possibility. It cannot be 5, because a perfect square ending with 5, 10th digit should be 2. But this should also be 5, because they both are B only, right? It cannot be 6. Any perfect square ending with 6, 36, 196. 10th digit should always be odd number, but 6 is not an odd number. It cannot be 7, it cannot be 8. Last thing, any perfect square ending with 9, if it takes 9, 10th digit should always be an even number, 49, all those things, 49, 169, but 9 is not an even number. So only possible cases are B should be 0 and B should be 4. Now if this becomes 0, what is the smallest perfect square? That means last 2 digits become 0, right? Last 2 digits become 0. What is the smallest perfect square, which if I square it, it will end with 2 zeros? It is 10 square. 10 square is 100. We know a concept in aptitude which we have learnt earlier, that x square and 50k plus or minus x whole square, both will always have same last 2 digits. That means 10 square and 50 minus 10, 40 square, this will also have same last 2 digits. 50 plus 10, 60 square, this will also have same last 2 digits. 100 minus 10, 90 square, this will also have same last 2 digits. 100 plus 10, 110 square. 110 square is not a 4-digit number, ruled out. So this is 1600, this is 3600, this is 8100. But the question says first 2 digits also should be equal. None of these are equal in the first 2 cases, the first 2 digits. So this is a ruled out case, right? This case is ruled out. Similarly, B should be 4. Last two digits will be 4, 4, 44. Smallest number when squared will should give you last two digits as 44. 12 square. 50 minus 12. The question says first two and last two should be equal. 50 minus 12 is 38. 38 square is 1444. 50 plus 12 is 62. 62 square is 3844. 100 minus 12 is 88. 88 square is 7744. If I take 100 plus 12, it is 112. 112 square is nothing but 5 digit number. It's not a 4 digit number. That means first two should be equal. It is not equal here. Here it is not equal. First two and last two are equal. So this is the case what they are asking in the question. Your question says how many such numbers are perfect square? How many such numbers are perfect square? Where first two digits and last two digits are also equal. There is only one such number, and that number is 7744. So answer is how many? How many is nothing but 1. Getting the idea? It's a very, very beautiful way of solving. Please know the concept and execute the concept so beautifully. Idea clear, sir? Please write on this. Before solving the next question, first of all, we will move on to CAT 2006 question. Now, before solving the first question in CAT 2006, now observe carefully, sir. Suppose I have 3 power 2 and 2 power 2, right? I have 3 power 2 and 2 power 2. 3 power 2 is 9, 2 power 2 is 4. Which is greater? 9 is greater. That means 3 square is greater than 2 square, right? 3 square is greater than 2 square. Because you know the value of 3 square as 9 and 2 square as 4, you could have easily told it. But the other way of telling is that if you observe the powers in both the numbers are same. When the powers are same, ignore the powers. Only concentrate and find out which is greater in the bases. That means if I ignore this power 2, only try to find out from the base 3 and 2 which is greater. 3 is greater than 2, so this should be greater, right? Suppose one more example, 4 power 100, 3 power 100. Ignore the power. I don't know what is 4 power 100 value. I don't know what is 3 power 100 value. If powers are same, ignore it and try to find out which is greater from the base. 4 power 100 should be greater than 3 power 100. Now let us solve the original examination question which is asked in CAT 2006. Now please see the question. Your question is which among 2 power 1 by 2, 2 power 1 by 2, 3 power 1 by 3, 4 power 1 by 4, 6 power 1 by 6 and 12 power 1 by 12 is the largest. Out of all these numbers, which is the largest is the question, right? Which is the largest. Now, what we understood is to find out which is largest or smallest, I may need to make the powers as same, right? I need to make the powers as same. Now, all these numbers should go and fall in the same number. What is that number? LCM. We have already discussed what is the usage of LCM or what is the application of LCM. That means 2, 3, 4, 6, 12. All these numbers will go and meet at a common number. That number is nothing but LCM. What is the LCM of 2, 3, 4, 6 and 12? It is 12. That means I should make all these numbers as power as 12, right? Power as 12 or maybe 1 by 12, whatever it is. That means 2 power 1 by 2. I can write, I should make it as this 2 should be made as 12, multiply by 6, multiply by 6, 6 by 12. So I can also write it as 2 power 6 power 1 by 12. Similarly, 3 power 1 by 3, multiply by 4, multiply by 4. It is 3 power 4 by 12. This I can write it as 3 power 4 power 1 by 12. Next, 4 power 1 by 4. I'll write it here, sir. 4 power 1 by 4. I should make the power as 1 by 12. Multiply by 3, multiply by 3. It is 3 by 12. It is 4 cube power 1 by 12. Similarly, 6 power 1 by 6. I should make it as 12. Multiply by 2, multiply by 2. 2 by 12. It is 6 square power 1 by 12. Last is 12 power 1 by 12. This is 12 power 1 power 1 by 12. Now if you observe carefully, power is 1 by 12 in all the values. In all the values, power is 1 by 12. Ignore the powers. Only concentrate on base, which is the greatest. 2 power 6, 64. 3 power 4, 81. 4 cube, 64. 6 square, 36. 12 power 1 is 12. Out of 64, 81, 64, 36 and 12. Which is greatest? 81 is greatest. That means this value should be the largest. Answer is 3 power 1 by 3. Very, very easy way of solving. Don't make it complicated. Very easy. When powers are same, ignore the powers, equate the bases. That means not equate, in fact, check out from the base. Whichever base is greater, that number will be the greatest. Right? Please write down. let us solve some questions on CAT 2004 number system question. Now, please write down the heading CAT 2004. Please see the first question. The remainder when 15 power 23 plus 23 power 23 is divided by 19 is how much? Now they are asking remainder when 15 power 23 plus 23 power 23 when divided by 19. What is the remainder? Now again we will solve it in two methods. Method 1. Now if I apply negative remainder concept, right? If I apply negative remainder concept, this will become remainder when 15 when divided by 19. Negative remainder is minus 4. Minus 4 power 23. 23 by 19 is plus 4. Plus 4 power 23. Whole thing divided by 19. Minus 4 power 23 plus 4 power 23 is 0. 0 by 19 is 0. Remainder is 0. This is one way of solving. One of the method of solving is that method. Now, method 2. Method 2 is by the method of a power n plus or minus b power n. That method also can be applied. Now, a power n plus b power n is always divisible by a power n plus b power n is always divisible by a plus b if n is odd. If n is odd, a power n plus b power n is always divisible by a plus b if n is odd. That means 15 power 23 plus 23 power 23, it is always divisible by 15 plus 23 if n is odd. Yes, n is an odd number, 23 is an odd number. That means this number 15 power 23 plus 23 power 23, this is always divisible by 15 plus 23, 38. That means remainder when this is divided by 38 is 0. Now think logically, any number which is divisible by 38, it is also divisible by 19, because 38 when divided by 19, it is remainder is 0. Next 38, next multiple is 76. 76 when divided by 19, it is remainder is 0. That means any number which is perfectly divisible by 38, it will also be divisible by 19, because 38 is nothing but the multiple of 19. Because this is true, this will also be true, and the remainder for this also will be 0. Both the ways you will get the same answer. Use negative remainder or use a power n plus or minus b power n. Whichever is easy for you, you pick that method. Multiple methods, you decide your method. Please write. Now we will solve some questions on CAT 2005. Please write down the heading. CAT 2005. Please see the first question. It's a very good question. The digits of a 3-digit number A are written in the reverse order to form another 3-digit number B. Right? I have a number called as capital A, which is a 3-digit number. If I reverse it, I will get another 3-digit number B. That is nothing but another 3-digit number B. Right? Now, next statement says, if B is greater than A and B minus A is perfectly divisible by 7, then which of the following is necessarily true? Right? Which of the following is necessarily true? Now, they are giving you the answer options as first option is A lies between 100 and 299. Second option is 106 less than A less than 305. Third option 112 less than A less than 311. Fourth option is 118 less than A less than 317. Any one of these should be necessarily true, right? That is what they are asking. Now see, they are telling A is a 3-digit number. The 3-digit number I will call it as XYZ. Now they are telling that if I reverse the digits of this 3-digit number, I will get another 3-digit number that is called as B, right? That is called as B. Can I write this A as 100x plus 10y plus z? Similarly, B I can write it as 100z plus 10y plus x. Now if I subtract one from the other, if I subtract b minus a, why should I do b minus a, why not a minus b? Because question says b is greater than a. You will always subtract bigger number and minus smaller number. So b minus a is nothing but 100z minus z, 99z, 10y cancels, x minus 100x, it is minus 99x. So 99 into z minus x, right? It is 99 into z minus x. But the question also says b minus a is perfectly divisible by 7. Now this b minus a, that means this, it should be perfectly divisible by 7. If this value has to perfectly divisible by 7, either this should be divisible by 7 or this should be divisible by 7. But 99 is not divisible by 7, right? 99 is not divisible by 7. Therefore, z minus x should be divisible by 7. Or in other words, z minus x should be a multiple of 7. It can be 7, 14, 21, 28 or whatever the value it is, right? Z minus x should be perfectly divisible by 7. Now think logically, z and x are single digit numbers. So if I subtract two single digit numbers, I will not get 2-digit numbers. So these all cases are ruled out. That means the only possibility is z minus x should be 7, right? Z minus x should be 7. Which all cases will give z minus x as 7? 9 minus 2 is 7. 8 minus 1 is 7. 7 minus 0 is 7. 6 minus of minus 1. But x cannot take negative value, right? So those are all ruled out. Similarly, x cannot take 0. If x becomes 0, it becomes a 2-digit number, ruled out. These are the only two possibilities. That means x should be 2 and z should be 9. Or x should be 1 and z should be 8. Now if I take the cases x, y, z becomes x should be 2, y I don't know, it can take any digit from 0 to 9, z should be 9. Similarly, x, y, z in this case is x should be 1, y I don't know, z should be 8, right? Now if you see the possible cases, suppose in the worst case scenario, if I put the maximum value for y, what is the maximum value y can take? 9. The maximum value y can take is nothing but 9. That means the x, y, z is nothing but a. A maximum value should be 299. That means a cannot exceed 299. 100% it is guaranteed that even if I put the maximum value for y, a cannot exceed 299. The maximum itself is 299. That means a cannot be 305, a cannot be 311 or a cannot be 317. These all three cases are eliminated. The only option left is option A. The maximum value it can take it 299 or it can be less than that. So it is A lies between 100 to 299. Idea clear? It's a very good question which needs little bit of thinking before you solve it. Idea clear, sir? Please write down. Fourth question. Now before solving the fourth question, please write down this point. Please write down this point, sir. Any prime number greater than 3. Any prime number greater than 3. Any prime number greater than 3 is always of the form. 6k plus or minus 1. Any prime number greater than 3, it is always of the form 6k plus or minus 1. But vice versa may or may not be true. It may be true or may not be true. But vice versa may or may not be true. Very important point. This we have discussed in detail in our regular class also, right? Now please see the next question. It is question number 4. Now please see the question. I think we have solved this question also in our regular class. The original CAT question we have solved in the regular class. Let us solve it again. If a plus 2 and a plus 4 are prime numbers, then the number of possible solutions for a is how much? Right now see here, they are telling that a plus 2, a plus 4, these are prime numbers. How many values a can take such that a plus 2, a plus 4, all three will become prime numbers? That is what they are asking. Now see here, listen to this carefully. The smallest prime number is 2. The lowest prime number is 2. If I put 2 for a plus 2 is 4, a plus 4 is 6. But question says these two also should be prime. All three are not prime here, right? Only one of them is prime. So this is ruled out. If I put the next prime number 3, this is 3, 5 and 6, right? Sorry, 3 plus 2, 5, 3 plus 4, 7, right? 3, 5 and 7. All the three are prime numbers. This is one possibility, right? This is one possibility. Any prime number greater than 3, it will be either of the form 6k plus 1 or it will be of the form 6k minus 1. 6k plus 1 plus 2, it is 6k plus 3. 6k plus 1 plus 4, it is 6k plus 5. This is a multiple of 3, this is a multiple of 3. If you add two multiples of 3, the answer also will be a multiple of 3. If the answer is a multiple of 3, it will not be a prime number other than 3, but it is not 3. So this is also ruled out. 6k minus 1, 6k minus 1 plus 2, it is 6k plus 1. 6k minus 1 plus 4, it is 6k plus 3. Multiple of 3, multiple of 3. Answer also will be a multiple of 3. So this is also not a prime number. How many prime or how many values A can take such that A plus 2, A plus 4 is a prime number is the question. How many values it can take? It can take only one value, and that value is nothing but 3. If I put 3 for A, 3 plus 2, 3 plus 4 also will become prime numbers. How many is the question? 1 is the answer. Idea clear? The key point is any prime number greater than 3 is always of the form 6k plus or minus 1. Vice versa may or may not be true. Idea clear, sir? Please write down. Clear, right? So these two will not be the confusing even if you upside down also. So the other thing is out of 12 confusing numbers, these two are not confusing now. So 10 are confusing. Out of 81, if 10 are confusing, remaining 71 are not confusing. Next. Third question. Now please see the next question. It is a question based on reminders. Now, question number 3. What is the remainder when 4 power 96 is divided by 6? Right? 4 power 96 is divided by 6. Now, multiple methods. Whichever the method you are convenient, you can follow that method. Method 1. Now, use the cyclicity process of 4. Now, 4 when divided by 6, remainder is 4. 4 square when divided by 6, 16 by 6, remainder is 4. 4 cube when divided by 6, remainder is 4. 4 power 4 when divided by 6, remainder is 4. So 4 power any number divided by 6, remainder is always 4. That is one way of solving. Method 2. Method 2. Now see here. Method 2, I can apply some other method what we have discussed in our regular class. 4 power 96 divided by 6. Now, I can apply Euler's theorem. 6 I can write it as 2 into 3. Sorry, it's not Euler's theorem, I am making use of Chinese remainder theorem. Right, it is Chinese remainder theorem. 6 is 2 into 3. That means remainder when 4 power 96 divided by 2. 4 when divided by 2 is perfectly divisible. So, 4 power 96 can be written as 2 into some constant. This is first equation. Similarly, remainder when 4 power 96 is divided by 3. 4 when divided by 3, it is 1. 1 power 96 is 1. That means 4 power 96 can also be written as 3 into some constant plus the remainder. Left hand side is same, equate the right hand side. So, if I equate the right hand side is 2a is equal to 3b plus 1. 2a is equal to 2b plus b plus 1. This is a multiple of 2, multiple of 2. b plus 1 should be a multiple of 2. For b plus 1 to be a multiple of 2, b should be 1. Right? B value should be 1. Substitute it here. If I substitute 3 into 1, 3. 3 plus 1, 4. 4 power 96 is of the form 4. That means the remainder 4 when divided by 6. What should be the remainder? 4. Answer is 4. You can apply Chinese remainder theorem also. Or you can apply the other method what we have discussed. When the numerator and denominator are not co-prime to each other. That method also what we have discussed in our regular class. You can apply that method, you will get the answer very easy. Idea clear? There are multiple ways of solving the question. Whichever method you are convenient, please make use of that method. If you are using that method, this is 2 power something, 2 power 2 power something. This is also 2 into 3, right? From there you can get the answer. When numerator and denominator are not co-prime to each other, you can apply multiple methods. Either way you will get the same answer. Remainder is 4. Please write down this.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free. AMC.